All right, very last example for solving trig equations, and then you guys are doing all the rest for review. So we've got the sine of 2x is equal to the sine of x. And we want to solve for the general solution equations, and then lastly where the points intersect on the graph. So we've got the sine of 2x and the sine of x. Now here's the problem. The angles again are different. 2x is not the same as x. So we can't combine these signs. We can't factor these signs. They're not like terms because the angles are different. It's the same thing as like having x squared versus x. We cannot combine them, so the only thing that's left to do is use the expansion for the sine of 2 times an angle and hope that we can see something happen there. So on the left hand side, the sine of 2 times that angle x is going to become 2 times the sine of x times the cosine of x. That is how we expand the sine of 2 times an angle. And then on the other side, we have the sine of x again. Okay, so again, a lot of people are going to say, well, let's just divide by the sine of x, and then we can see the sines of x go away. But remember that rule, we cannot divide to cancel. We divide to cancel, and we're going to lose half of our solutions. So instead of dividing by the sine of x, what I'm going to do is I'm going to subtract the sine of x from the right-hand side, move it over to the left so that the right-hand side is 0, and then we can apply that zero product theorem that we've been talking about. So all that I can do now is I can factor a sine out of both of these terms. I'm going to make this a different color. That is going to leave us with 2 times the cosine of x minus 1 on the inside. And now we have 2 factors. And if these 2 factors multiply to 0, then either one or both of these factors must be 0. So the sine of x must be 0, or 2 times the cosine of x minus 1 must be 0. Okay. 2 things happen. So we get a principal value here. This is the angle whose sine is 0. The angle whose sine is 0, that is 0 degrees, 0 radians. And then this one is going to be the angle whose cosine is 1/2. Now the angle whose cosine is 1/2 is pi over 3. So 2 principal values, and we are going to make sure that we use the correct general solution equations to represent each of these. Okay, so principal value of 0, that came from using inverse sine. So we're going to use these sine equations to get the first 2 general solution equations. All right, here we go. For sine, it is going to be the principal value plus 2 pi n. I'll leave that 0. I'm not going to mark you off if you leave the 0. I like seeing that because I can see what the principal value is very clearly. Second general solution equation for sine is always pi minus the principal value. So pi minus 0 is just pi. And then we move on to the 2 general solution equations that came from cosine. So that principal value pi over 3 came from inverse cosine, which means these 2 equations are going to follow the cosine equations. So that is the principal value plus 2 pi n. And then that is also the negative principal value plus 2 pi n. So together, these 4 equations make up all of the general solution equations for this problem. And now we move on to the particular solutions. So again, we're going to move on to those solutions between 0 and 2 pi. Now, on the graph, we're going to make sure that we mark the ordered pairs. So I'm going to start. Now, we're looking for where these 2 curves intersect, and it's kind of hard to see here, but the first intersection point is actually at 0, and that aligns with one of the first solutions that we're going to get. Moving from left to right, because we're going to mark smallest to biggest, and that's going to help us get the order correct here. We've got that point B up there, and then we've got C that's sitting on the x-axis again. And then we're going to have one more point down here at D. Now, technically, there's also a point of intersection right there, okay? But that is at 2 pi. We are restricting our solutions to be between 0 and 2 pi, but not equal to 2 pi. We can equal 0, but we're not going to equal 2 pi, and that comes from this parenthesis here on the outside of that 2 pi. So we're not going to mark this last solution as part of the solutions between 0 and 2 pi. So we're going to ignore that point there. Okay, so only 4 we're looking at. All right, so if we're looking at the particular solutions between 0 and 2 pi, go back to your general solution equations. Think about that table if you need to. Again, I'm not going to show the table, but this is where you'd start plugging in values for n and seeing what lies between 0 and 2 pi here. Okay, if I were to do that with the table, these are the values that we would end up with. The first one is 0, okay? 0 radians, that's going to be point A. All right, next we would end up with pi over 3. That would be point B. And then after that, we'd get pi when n is 0 from that second general solution equation. And then the last solution is going to be if we take theta 4, the fourth equation, and make n1. That's going to yield 5 pi over 3. And that's our fourth point, D. Okay, so last thing we've got to do is we have to find the y values for each of these ordered pairs. And again, we're going to take that back and we're going to plug it into one side of the equation. Only one side. Take your pick. They're equal to each other, which is why we only have to pick one. I'm going to pick the easier one. I'm going to pick the sine of x. I'm going to plug everything into that and evaluate the y value. So the sine of 0 is 0. So 0, 0 is that first point A, and that's at the origin. So that lines with what we've got on the graph. Okay, the next one, the sine of pi over 3, well, that is root 3 over 2. So the y value here must be root 3 over 2. Okay, and that's pretty close to 1. It's like 0.8 something as a decimal. All right, moving on, the sine of pi is 0. And again, we see that point C sitting on the x-axis. That would make a y value of 0. And then lastly, 5 pi over 3. The sine of 5 pi over 3 is negative root 3 over 2. 5 pi over 3 is in the fourth quadrant. So again, that aligns pretty closely with what we've got on the graph here. It's about negative 0.8 something. So those are the particular solutions for this system, or this equation. Okay, so last thing before you guys practice the rest of the worksheets that I gave you, just make sure that to find the y values, you always go back to the original equation and pick a side. Right or left, it doesn't matter. You only need one. All right, email me if you guys have any questions. Good luck and stay safe.